Good day to everyone. I'm Dr. Ganesha Balamurugan. I'm dealing with the subject of metrology and measurements. In this session, we are going to learn about linear measurements. This is the introduction about the linear measurements. And these linear measurements is the measurement. It's the very fundamental, right? Because all the measurements starts with the linear measurements. For example, length measurements, right? So what are linear measurements? The measurement of perpendicular distance between 2 points or surfaces designed either for line measurement or end measurements. So as per this definition, for example, I want to measure, I will show now. So there are 2 points here, two circles here. Consider these as 2 points and I want to measure the distance or length distance between these 2 points. So this method of measuring the distance between these 2 points or two circles is linear measurement. If I want to measure the length of this slide, okay, so I want to measure the length of this slide, and I can use an instrument to measure the length of this slide. What will be the length in mm or centimeter or inches per maybe? So this method is called linear measurement. So it applies. So whatever thing comes under this linear measurement. So length, you can the measurement of length, heights, diameters, thickness, and the radius, etc. These things are comes under linear measurement. Even though linear measurements means not only confined to the length or distances, it also includes the heights of the objects and diameter of the circular objects, thickness, and the radius. So these things also included in the linear measurements because we are there is no angularity is present in this. All the measurement there is no angularity and they are geometrical dimensions. So geometrical dimensions other than angular measurements are mostly grouped as linear measurements. Okay, so we can classify these linear measurements into two main categories. One is direct measurement instruments and indirect measuring instruments. So as of I explained earlier, so you have to take a steel rule and measure the length of a object. Then you are directly coming to know the length of the particular uh, object by using a instrument. This is direct measuring instrument. And indirect measuring instrument means, and after measuring the length of the object, and you fix that and ensure the length. After ensurement, then what you will do, you are comparing that length with other object. As a, I'm taking this already measured object as a reference object, and you are comparing these two lengths and comparing the length of the reference object with the unknown length, unknown object, and this is called indirect measurement. Here you are not using any instrument, right? No instrument is used. Otherwise, some indirect measurement instruments also available. So these are called calipers, screw gauges, that we will discuss in the subsequent slides. Mostly, the direct measuring instruments contains graduations in their scales. So graduation means some values will be indicated. So you can directly come to know and you can accurately identify the exact value of that object. That is what measuring system. Okay, measuring system. So for example, if you are measuring the length of the object, you can exactly measure how much length the particular object possesses, right? So by using the graduations engraved in the measuring instrument. For example, scale. Take scale. In the scale that you can say you can top and bottom you can find many graduations, many small and big lines are present. At the end, they mentioned centimeter and inches, and that means each and every small and big lines indicates the some increment value of the centimeters and the inches. So while using that scale, if you uh, keep it along with that object, and if you're measuring the length, using the graduations or that particular small and big lines, you can directly come to know the value of the length, right? And these indirect measuring instruments, so mostly never contains the type of graduations. The examples of these non-graduating instruments are calipers, wire gauges, screw pit gauges, radius gauges, thickness gauges, and slip gauges, right? Because they have already measured, they have some measured dimensions or standard dimensions. Using that as standard dimensions, by comparing with these standard dimension with unknown object dimension, we can match it and come to know the dimension of unknown object. So this is non-graduate instrument. It comes under indirect measurement. So what we are seeing now here is the few examples of and instruments, examples of used that instrument used in the direct and graduated measurements, right? So this is vernier caliper, and this is screw gauge, and this is height gauge, and this is depth gauge. So these having some graduation, and we can directly measure the value of particular length, diameter, and depth of objects. And these are called non-graduated instruments. You can see the calipers. These are called calipers. I have already mentioned, and the screw pit gauges and wire gauges. So these calipers, you can see there is no graduations or details are present in the calipers. Using the calipers, first you have to measure the required dimension, but it never shows the value of what value you have exactly measured. So it needs a graduated instrument or measuring instrument. So by comparing with the scale in the graduated instrument, you come to know the exact value. I will show one video, so then you will appreciate the usage of how they are these and use of these non-graduated instruments like calipers. Please. So, in this video, you're going to see how these non-graduated instruments like calipers are used uh, in the indirect used for the indirect measurement. I will share the sound of this video with you. Please listen. I will explain in between.
Today we're going to have a look at calipers. These are a tool that was commonly used in a bygone era, but will still be found in the toolbox of the machinist. This is a set of outside calipers, and this is a set of inside calipers. You can tell by the measuring edges. These are meant to measure inside diameters, and these two measuring edges are meant to measure outside diameters.
So this is outside calipers and inside calipers. How they are naming these or classifying this outside diameter, inside diameter, based upon the measuring edges. So these measuring edges are curving inside in the outside calipers. Mostly they will use to measure the outside value, dimension of the object. And here in the inside calipers, that measuring edges are carving outside. It is mostly used to measure the internal dimension of the object. They will explain, please watch the video carefully. They will explain how to use these two calipers with the different forms.
These happen to be spring joint calipers. So as I squeeze them, there's a spring that loads onto a nut. I can adjust the size of the measuring tips by adjusting the nut. These actually have a really unique feature where
So using this nut, this is spring actuated calipers, and the gap between this measuring edge can be modified or adjusted by these screws.
if I squeeze it a little bit, I have a split nut that can actually open up and slide quite easily up and down the thread. But if I put a little bit of pressure on it, now I can adjust that split nut on the thread, and it will turn the calipers in or out. The idea behind these calipers is to measure roughly over the outside of a piece of stock or on the inside of a piece of stock. So if we take a piece of pipe for
So for the demo, we have taken a hollow section. So this is a hollow bar, and in this hollow bar, there has an outer diameter and inner diameter, and both these outer between the outer diameter and inner diameter, the value is that wall thickness. This is wall thickness. Now they are going to demonstrate how to measure the outer diameter of this hollow section or hollow bar using this outer caliper.
example, and I put the caliper over it, you can see it doesn't go. But if I adjust this nut with my one hand, I want to turn it back until it just slides over. And then I'll turn the nut.
So initially, they faced the difficult to insert these outer diameter between the gaps in the measuring edges, and by adjusting the screws, they can able to increase the gap between the measuring edges. Now they can fit the outer diameter of this section exactly between them.
Until I just feel a little bit of drag with both of these measuring faces being on the same plane. In other words, I don't want to twist it. I want to have it across the same plane and get just a little bit of drag. Now you will notice that there is no graduation on this tool. So what I would have to do is I would have to take another tool with a scale and put it up against this tool. This is called a transfer type measuring tool, and this is transfer measurement. I would then
So
hold
now
the
you
rule.
can see, now you can appreciate the video. So I have taken this video as example to show how these non-graduated and indirect measurement instruments can be used. They measure the outer diameter, and they now matches. They never know what is the value of the diameter, but how, because there is no graduation in this instrument, in this caliper. So only way is they have to match with the graduated instrument. Okay, this graduated instrument, now here what they are using here, steel rule, and by comparing this, they measuring the gap using the steel rule, they come to know that exact diameter of this hollow section.
Up against the one measuring face and measure out to the size required. In this case, it would be 2¼ inches. Because it is a transfer type measuring tool and you may not have a lot of experience using this tool, I would suggest that you try to take the measurement at least twice and see if you get the same size. The other tool is the inside.
Now they're going to give the demonstration about the inside caliper, how to use the inside caliper. And mostly these inside calipers are used to measure the hollow section, inner diameter of this hollow section. You have to see how they are demonstrating.
Caliper, and this happens to be an inside spring joint caliper. How these would work is I would set it inside a bore on the one leg, And again, I would be adjusting the nut up top. Now what I want to do in the bore, as I'm adjusting the nut, is I want to have it sit against the one surface of the bore, and I want to wiggle the top one back and forth as I'm turning the nut. And I also want to have the caliper go into the bore and back. And I just want to be able to feel the highest point until it just drags. So what I'm going to do is I'm going to set it inside the bore, and I'm going to hold this bottom leg in place, and I'm going to have the nut come in a little bit, and then I'm going to move the tool back and forth and in and out until I just get a little bit of drag on it. Now this is a little more tricky than using the outside.
So they're using this internal caliper. First they inserted these two edges of this internal caliper, and one end they fixed with one portion, one edge, and the another edge they are tracing the profile, inner diameter profile from the this edge to this end to another this end, to confine that what is the maximum height or any other height differences or surface flatness, flatness and differences in the surface flatness present or not. And by ensuring this one, then they will take out this caliper and they will compare with any other, some other standard measuring instrument, that is graduated measuring instrument, and they will find out the diameter. Let's see how they are doing this.
Calipers. The inside ones require a little more skill. Now I have the size set. I want to be very, very careful I don't hit this nut changing the size of these measuring points. What I would do now is I would then take some type of a measuring tool.
So here in this example, in previous example they have used a simple steel ruler. In this example they have taken the screw gauge. Screw gauge is one type of graduated and direct measuring instrument. Mostly these screw gauges are well suitable to measure the diametrical sections of the components. So here they have taken this instrument to find out the measurement taken by this caliper.
In this case, I can choose a micrometer, and I can measure across the face until we get the size required. So what I would do is set it on the one leg, measure it back and forth and in and out. Again, now that we have the size of that bore, I would hold the one leg against the far end of the micrometer. I would start to move the thimble of the micrometer in towards the other leg as I'm moving the caliper across the measuring face and also back and forth across the micrometer till I got the same feel that we had inside the bore.
So one thing you have to keep in mind that you can ask a question that why need to use the same micrometer or any other direct measuring instrument to measure that inner diameter of this hollow section or outer diameter of hollow section. There is a limitations are there. For example, the diameter of outer diameter of hollow sections are very large. Okay, you can maybe these screw gauges, these measuring gaps are very limited, are standard. So it's very difficult to measure these diameters here, and we cannot able to insert this whole section into the screw gauge. And most probably, another big challenge is measuring the internal diameter. Even we can able to measure, we can try and we can able to measure the outer diameter, but very difficult to measure the inner diameter. How we can measure the inner diameter using the screw gauge? It is not possible. Even steel rule also we can measure this length between that edge to this edge, but it may if you keep the scale at you have to perfectly have to keep the scale exactly perpendicular to the axis of this hollow section. If you are not able to keep the perpendicularity, what will happen if you have show any deflection, if you have show any angularity from the perpendicular axis of this hollow section, what will happen? You cannot be able to find out the exact measurement of this hollow section. So to avoid these difficulties, we can use these ungraduated instruments, and using this instrument we can detect or measure the internal diameter, and we can compare it with the standard or non-standard. We can, I cannot say it is a, this is also standard. Okay, it is graduated instruments or direct measuring instrument. You can get the numerical value of the internal diameter.
And this part is very close to 1 3/4 inside diameter, 2 1/4 outside inch diameter, 2 1/4 outside inch diameter, 1 3/4 inside diameter, so it would have a 1/4 inch wall thickness.
So now you can able to appreciate how these non-graduated instruments can be used as indirect measurement instruments, and what are the usage and applications of these non-graduated instruments. Now we will go for, this is one example of how to use how to use that steel rule. Even the steel rule we can use it properly. So this is a wrong method. So if you want to measure the height of this bar, you have to keep the steel rule touched with that particular object. So the both edges would be touched together. Otherwise, if you keep any distance, small distance also, you cannot able to measure the identify or measure the exact value of height of this object. This is one type of human error. In the previous chapter, we have studied about different errors. One type of error is human error, and because of unawareness or unskilled labor, that human error will occur. And this is one type of human error, that is that particular employee never know how to properly use the scale. So vernier caliper. We will start with the concept of the vernier caliper. Vernier calipers are one of linear, uh, very basic and a very important linear measurement instruments that to direct and graduated measuring, graduated type of measuring instrument. If you are mechanical engineer, you should know about the components of this vernier caliper and how to use that vernier caliper. If you don't know how to use the vernier caliper, then it will be very difficult for you to survive in many industries, because vernier calipers are very, very basic measuring instrument for every mechanical engineering and manufacturing applications, right? And these are the components of these uh, vernier calipers. It contains two scales. But now one is main scale. How you can see here, this is the main scale, and another one is vernier scale, and the main scale having the higher graduations when compared to the vernier scales. So why these vernier scales are present means, here the least count is playing the important role. Least count means accuracy. So what is meant by least count? The ability of measuring a small variation and small length also is called least count. For example, if you are measuring measuring the length of a block, okay, three-dimensional block, and if it shows, normally it shows with scale, the steel rule, 10 centimeter, then that is not exactly maybe 10 centimeter. So it may be a 10.1 m, 10.1 centimeter. So the zero point 0.1 centimeter cannot be measured with the normal or conventional steel rule. But using the vernier caliper, you can exactly measure the 10.1 centimeter because of that least count concept involved in this vernier caliper, right? So we will see what is meant by least count. Then we will reach on to the how we can use this vernier caliper. First of all, first keep in mind about the components of this vernier caliper. And this is the locking screw, we can move this vernier scale front and back along that main scale, uh, and we can lock it wherever we want. We can lock that vernier scale on the main scale portion, and you can see these are external measuring jaws. These are external measuring jaws, and they are internal measuring jaws like calipers we have seen in the last video. Okay, one is fixed jaw, another one is moving jaw. This moving jaw is attached with vernier scale portion, so we can move it, right? And we can do the fine adjustment with this instrument. And for depth measuring also we can do with linear scale. Okay, that is why it is called basic of all measuring linear measuring instrument. So like lathe, how lathe is very basic manufacturing equipment used in the production engineering. Likewise, here for metrology, especially in the linear measuring systems, linear caliper is very basic one and standard one. So this is the concept of least count. And the least count we have already seen the concepts of main scale and the vernier scale. So how to find out the least count? So first check that the 49 main scale divisions. So 49 main scale division that is present in the main scale, which is equal to 50 vernier scale division, that is small scale, that is moving scale. Okay, so to find out what is the one main scale division is, that one main scale division is 1 mm. Okay, one main scale division is 1 mm, but we have to find out what is the one vernier scale division. Okay, and one vernier scale division is, to find out one vernier scale division, this is the methodology to find out. So that is 49 main scale division divided by how many vernier scale divisions are there? 50 vernier scale divisions. So if you divide it, you will get the 0.98 mm. Okay, so one main scale that least count is the least count is uh, 1 mm minus 1 main scale division minus 1 vernier scale division. That is 1 mm minus 0.98. One vernier scale division is 0.98 mm. One main scale division is 1 mm, and one vernier scale division, the small division, is 0.98 mm, not exactly 1 mm. You subtract these two things, you will get 0.02, and 0.02 mm is the least count. So these vernier caliper can measure 0.02 accuracy, measure the length of the any object with 0.02 mm accuracy. For example, that length of that object we are measuring with is normal steel rule with 100 mm. Then if you measure the same length of the object with vernier scale, it will measure 100.02 mm. So that much of accuracy it will we can do with this vernier scale. Okay. So we will see that video. I will show a video how they can use that vernier scale. Then we will proceed with that.
Hi, I'm Bob Welds, and this is how to read a metric vernier.
Now you can see, I will run this video and watch this video how they can explain about the vernier scale and how they are going to measure the objects components with the vernier scale.
Hi, I'm Bob Welds, and this is how to read a metric vernier caliper. There are different kinds of vernier scales designed to do different jobs, but they all work pretty much the same way. Today, we're going to look at a metric vernier designed to measure to the nearest 1/50th of a millimeter. That is 0.02 millimeters. See how 1 divided by 50 equals 0.02? Now, the first thing we're going to measure with our vernier caliper is nothing. That's right, we'll measure 0. It may sound like a silly thing to do, but we're going to do it for a couple of reasons. Let's do it and you'll see what I mean. You see, when the calipers are fully closed, measuring 0 width, you can see the places.
So you can see what they are explaining. First, you have to ensure the zero, and zero of vernier scale exactly should match with the zero of the main scale. So it shows that the instrument is working properly and it is calibrated properly. If there is a mismatch between these two zeros, then it shows a wrong reading. Okay.
where you can take measurements. These surfaces are where the two parts of the calipers line up. You'll also notice that there are gaps in a couple of places on the calipers. These are not places to take measurements, so don't mess up by putting something in one of those gaps. Now, with the calipers closed, you can see where you're supposed to read the main scale. There are two scales on a vernier caliper, the main scale and the vernier scale. I'm going to erase the vernier scale and let you just look at the main scale first. You see, the zero mark points to the place where you're supposed to read the main scale. Right now it points to 0. Do you see that? Good. Let's read the main scale first. It's super easy. I'll close the calipers on this workpiece and we'll
So now they are measuring a diameter of a component, and they will show what is the value, or how to read that diameter in this scale.
see what the main scale says. These marks represent whole millimeters. So the reading is 1, 2, 3, 4, 5, 5 millimeters. Just be sure to look at the 0.
So diameter of the particular the circular object is 5 mm. So 0, 1, 2, 3, 4, 5 mm. Okay. Why? Because this zero of the vernier, where the zero of the vernier scale is matching with the graduation present in the main scale. So this is the main reading. So again I'm telling where that the zero of the vernier scale is exactly matching with the main scale graduation is the main reading. Here it is matching with the 5 mm because each each and every graduation is 1 mm. Okay, so now it is in the 0, 1, 2, 3, 5, fifth graduation it is exactly matching. So that the diameter of the particular circular section is 5 mm.
mark and not at this part. That's a common mistake and it'll give you the wrong reading. So the reading is 5 millimeters. That's pretty easy, right? Before we move on to the vernier scale, let me show you what it's going to tell us, okay? Let's say when we looked at the main scale, the reading wasn't right on the mark like it was last time. Let's say it looked like this. See how the mark is between 5 and 6?
So what they are saying previously in previous measuring condition that the zero of the vernier scale is exactly matching with the one of the graduation in the main scale. So we can easily identify that is a 5 mm. But in another measurement, it shows it never matching the main zero of the vernier scale is never matching with any of the graduation in the main scale. In this example, it is between these two graduation. These two graduation are lines. So these two graduation means what? 0, 1, 2, 3, 4, 5, and 6. So between the 5 and the 6 mm, this zero of the vernier scale is present. So how we can now able to find the value? So because it is not matching with 5 or it is not matching with the 6 and it not matching with any other graduation, it is in between the 5 and 6. Then what is the exact value and the exact measurement that they are going to explain?
6 millimeters? It looks like it's a little beyond halfway. You see, the vernier scale is going to tell us almost exactly how far over the mark is. Okay, you're ready to see the vernier scale, but I'm only going to draw the main part of it first. Now, you see the marks number from 0 to 10. Each of these marks represents a tenth of a millimeter. They're going to tell us the tenth.
So, so each and every graduation is zero point 0.1 mm. This is zero point 0.1 and zero point 0.2, 0.3, 0.4, zero point 0.5. So totally 10 graduations are present in the vernier scale, and each graduation is considered as 1 of tenth of the scale. So that means this is one means 0.1, okay, and 2 means 3 means point 0.3, point 0.4, point 0.5, point 0.6, point 0.7, point 0.8, point 0.9, and point 10. This is how we have to read the graduations in the main values, the major values or major numerical values in the vernier scale. But in the vernier scale, but in the main scale, you can see 0, 10, 20 means directly you can say read the 0 mm, 10 mm, 20 mm, 30 mm, 40 mm. And between 0 to 10 mm, each graduation is 1 mm. 1, 2, 3 mm, 4 mm, 5 mm, 6 mm, 7 mm, 8 mm, 9 mm, and 10 mm, 11 mm, 12 mm, 13, 14, 15 mm, 16, 17 mm, 18 mm, 19 mm, 20 mm. This is how we have to read in the measurements in the main scale. But in case of vernier scale, between 0 to 1, and this one is 1 of 10, that is 0.1 mm, and this 0.2 mm, 0.3 mm. Like this, you have to read. And here in the main scale, between 0 and 10 and 10 to 20, each graduation is considered as 1 mm. But here, between these two, 0 to 1 and 1 to 2, each graduation should be 0.02 mm. That is the least count. Already we have seen in the previous slide. That is least count. Each and every graduation, there are 10 graduations will be there. Maybe 5 or 10 graduation will be there. 5 graduation, I think. Yes, the 5 graduation will be there, and this 5 graduation each contain 0.02 mm.
Of a millimeter, and here's how they work. Look carefully, and you will notice that one of the marks on the vernier scale lines up better with the main scale marks than the others. Which one looks like it lines up best to you? I'll zoom in and let you look. Let me show you a hint about where to look on the vernier scale to see where the marks line up. You see how our pointer was a little more than halfway between marks? That means the vernier scale will line up a little past halfway. Now, do you see the mark that lines up better than the rest? It looks like the 7 is lining up. The 7 means 0.7.
So now we have seen that 0 is come away from the 5 mm graduation line, and you have to find what is the exact position this 0 indicates. Means to identify this, you have to check which line, vernier line is exactly matching with the main scale line. Okay, here 0 is not matching. Apart from 0, because 0 is not, if 0 is matching means no problem. But 0 is not matching, but we have to find the exact value. Then what we have to do, we have to find apart from 0 which vernier scale line is matching with the main scale value. If you closely look out this, closely look out all the lines, okay, you can see in this example the 7 is exactly matching with the 40, this main scale one. Okay, don't take this 40. So our intention is not 40, only 7. Okay, and this 7 means what? As per the vernier scale, it is 0.7, right? So that is why they are explaining. Let's see what they are doing.
Millimeters. But this caliper can measure even more accurately than that. I'll redraw all the marks and let you look again. Now, see that the mark next to the 7 lines up best.
Now what they are saying, now there are 5 graduations between major graduations of the vernier scale, 0 and 1. And each and every graduation here, 1, 2, 3, 4, okay, 5. So each graduation as marked as 0.02 mm. That is, we have calculated the least. This is the least count that we calculated in the previous slide. And as per this, again they are saying which line, not only major line, which small lines also matching with the exactly with the main scale. You have to check all the lines, and which line is exactly matching with the main scale division. Now, after 7, you can see next to the 7, another line, small graduation in the vernier scale is matching with the main scale. So how now we can read the reading or diameter of the particular component.
But what is the value of that mark? Remember how this caliper had a label that said .02 on it? That is what each mark is, .02 millimeters. Let's count up on the vernier scale to be sure we've got it. This 6 would be .60, the next mark .62, then .64, .66, .68, .70, then .72. The reading is 5.72.
So that means that reading is how to read this. This is 5 mm. Okay. After 5, but this 0 is not matching with the 6. It is in between the 5 and the 6. So, but it is near to the 6, but we don't know the exact value. So it is a 5 point. Okay. So the 7 is matching with the 7 after the line that is after 7 is exactly very exactly matching with the main scale. So how to read these one? So each and every small divisions in the vernier scale is 0.02. So this is 0.02, 0.04, and 0.06, and 0.08, and zero point 0.1, 1.2, 1.4, 1.6, 8, and zero point 0.2, and 0.2224. Like this we have to read it. But like this here, this is zero point 0.7 and this is 0.72. Okay, so totally this is this mark, the 0 is after 5, it is near to 6, but not never touch the 6, so it is 5 only. So 5.72, this is the exact reading diameter of the particular circular bar.
Millimeters. Pretty neat, huh? I'm going to let you try a few. We're going to start off easy.
So this is the methodology of doing measurement in the vernier scale. In the subsequent lecture, we will see in detail about the other linear measurement instruments and more detail about the vernier calipers. Thank you very much.